Black holes might lead to other universes or dimensions. Some theories suggest that black holes could be portals to different parts of our universe, or even gateways to alternate realities. Although these ideas remain firmly in the realm of speculative science, some speculative theories propose that if we were to find a way to harness the energy around a rotating black hole, we might be able to manipulate spacetime and potentially create a pathway to the past or the future. The idea of black hole time travel, though captivating, remains speculative and full of mysteries. The existence of dark matter, a mysterious form of matter that doesn't emit light and remains invisible to our telescopes, has intrigued scientists for years. Some theories propose that black holes could be composed of dark matter, providing a connection between these two enigmas. As objects approach a black hole, time dilation becomes extreme. This phenomenon means that an observer watching from afar would see events near the black hole unfolding in slow motion. The time-bending effects around a black hole create an eerie and fascinating visual spectacle. Supermassive black holes reside at the centers of galaxies, including our own Milky Way. These colossal cosmic behemoths can influence the orbits and behaviors of nearby stars. But much about their formation, growth, and interaction with their surroundings remains shrouded in mystery. Just outside the event horizon lies an intriguing region called the photon sphere. In this zone, photons, particles of light, can orbit the black hole, creating an eerie halo-like effect. Observing the complex light paths in this area can yield insights into the warping of spacetime. Black holes can produce multiple images of the same object, leading to the illusion of seeing echoes of distant galaxies. The extreme gravitational forces around a black hole can warp and twist the fabric of spacetime itself. This can lead to the creation of closed time-like curves, pathways through time that could theoretically allow for time travel. While we have strong evidence for the existence of stellar mass and supermassive black holes, the possibility of intermediate mass black holes remains a mystery. These hypothetical objects could bridge the gap between the known sizes of black holes and provide insights into their formation. If sound could travel through the vacuum of space, a black hole might emit an eerie, deep rumbling sound caused by its gravitational forces distorting nearby gas and dust. At the heart of a black hole lies an enigmatic region known as the singularity. Here, all known laws of physics break down, and our current understanding of reality cannot describe what happens. It's a point of infinite density and curvature, shrouded in mystery. When something falls into a black hole, it seems to disappear. Black holes merge and radiate Hawking radiation, which is thought to lead to their eventual evaporation. If a black hole evaporates completely, what happens to the information of everything that fell into it? This mystery underscores the tension between quantum mechanics and general relativity. While we have strong evidence for the existence of stellar mass and supermassive black holes, the possibility of intermediate mass black holes remains a mystery. These hypothetical objects could bridge the gap between the known sizes of black holes and provide insights into their formation. Black holes continue to challenge our understanding of the universe. They raise profound questions about the nature of space, time, matter, and energy, pushing the boundaries of human knowledge and inspiring both wonder and bewilderment among scientists and the curious alike.